Memory foam, the computer mouse, and the scratch-proof coating on our glasses are all thanks to space exploration. But what about solar panels? NASA didn't invent solar panels, but space exploration helped get the technology to where it is today, on our planetarium roof. When sunlight hits layers of silicon inside solar cells, an electric charge builds up, creating a flow of electricity. After launching a satellite or spacecraft, you can't keep bringing it back down to Earth to refuel it. They have to be powered by batteries or a renewable energy source. So what do we have endless supplies of in space? Sunlight. Solar panels, or arrays when there's lots of them, started off small. The first ones used in space being 5 centimetres squared on Vanguard 1. But they had to grow in size and effectiveness to power things like our Meteosat 7 weather satellite. The Soyuz spacecraft that carries people to and from the International Space Station, and the ISS itself. For the ISS, NASA and its partners developed a method of mounting solar arrays on a blanket. The blanket could be folded like an accordion for delivery to space, and then spread out to its full size once in orbit. Each of the 8 solar arrays on the ISS is 112 feet long. That's nearly as long as our astronaut footprints. Here at the National Space Centre, we're the proud home to 742 solar panels. They generate the equivalent of around 46 homes worth of electricity per year. It's just one of the ways we're trying to be more sustainable. Unfortunately, solar panels are at the mercy of the weather, especially here in the UK. So what if we put solar panels up there in space? It might seem like science fiction, but space-based solar power systems are actually being considered to help us move away from fossil fuels. A space-based solar power system involves a solar power satellite, an enormous spacecraft equipped with thousands of solar panels. These panels generate electricity, which is then wirelessly transmitted to Earth through high-frequency radio waves. A ground antenna is used to convert the radio waves into electricity, which is then delivered to the power grid. Like solar panels on Earth, the plan isn't perfect. We wouldn't have to worry about a cloudy day or nighttime getting in the way, but transporting all the parts needed into space is very difficult and costly, and it will take a toll on the environment. And at the moment, transmitting energy from space to Earth isn't very efficient. So there's still a lot of work to be done and problems to solve, but maybe a future scientist or engineer will come up with a bright idea to help us harness the power of the sun.